Welcome to the Explainer. So if you've opened a tech blog or honestly even just talked to a coworker recently, you know we're basically living in the future. But that future comes with a massive tidal wave of jargon, right? It can feel a little overwhelming when literally every new app or service claims to be powered by some futuristic technology. Well, today our goal is super simple. We're cutting through the noise and demystifying the most common tech acronyms of 2026. We're going to unpack the AI Russian doll.
AI, ML, DL. Seriously, what's the actual difference? We live in an AI-powered world, from the voice assistant sitting on our kitchen counters to the systems telling us what to buy next. But people constantly use these terms interchangeably. You know, you'll hear someone say AI when they really mean machine learning, or deep learning when they just mean a relatively simple, smart algorithm. The thing is, they actually mean very different things, and pinning down exactly what separates them gives you a massive advantage in understanding where technology is truly heading without getting swept up in all the marketing hype.
So, here's our roadmap for this explainer. We're going to unpack these terms exactly like a set of Russian nesting dolls. We'll start broad with the AI umbrella, zoom into what is machine learning, and then crack open the innermost doll by diving into deep learning. After that, we'll put them head-to-head in the ML versus DL showdown, examine the fuel that powers them in the big data engine, and finally wrap things up by mapping out your AI learning path for 2026. Okay, let's jump right into Section 1, the biggest, outermost layer of our technological Russian doll, the AI umbrella. Let's start super broad. Artificial intelligence is basically the grand umbrella term for the whole field. At its core, it's really just the ability of a machine to imitate human intelligence. We're talking about enabling systems to think, learn from data, and make decisions, all without explicit human intervention. AI is the overarching goal, right? Creating intelligent machines capable of problem-solving, pattern recognition, logical reasoning, and ultimately adapting to get better over time. It is the big dream that encompasses literally everything else we're going to talk about today.
But we do have to make a really crucial distinction here. There are two main types, narrow AI and general AI. Narrow AI, also called weak AI, is what you and I interact with every single day. It's designed to perform a very specific, focused task. Think of the virtual assistant setting your morning alarm or the facial recognition instantly unlocking your phone. It's highly specialized. General AI, on the other hand, that's the sci-fi stuff. That's a system possessing human-level cognitive abilities across multiple domains. It can reason, adapt, and learn anything a human can. But hey, don't worry, Skynet isn't self-aware just yet. General AI does not currently exist. It firmly remains a future research goal.
All right, let's open up that big AI doll and zoom in one level deeper to our second section. What is machine learning?
Machine learning, or ML, is a specific subset of AI. And honestly, this right here is the engine driving today's tech revolution. The real magic trick is baked right into the definition. It works without being explicitly programmed. So, instead of a human sitting there typing out a million if-then rules for every single possible scenario a computer might ever encounter, ML algorithms are designed to just find patterns in historical data all on their own. The machine literally learns from experience, continuously improving its performance as it processes more and more information.
So how does that learning actually happen? Well, it's basically a four-step pipeline. First, you feed the system data. That's your raw information collected from all sorts of sources. Second, you apply an algorithm, which is essentially just the mathematical method used to crunch all that raw information. Third, this training period yields a model, the learned output that actually captures the patterns. And finally, you use that model to make a prediction or decision based on completely new data. Data, algorithm, model, prediction. It is an amazingly elegant loop.
Let's anchor these abstract concepts to the real world. Where are we actually using this today? Pretty much everywhere. When Netflix suggests a movie and you end up binge-watching until 3 a.m., that's an ML recommendation system analyzing your past behavior. When your bank suddenly flags a weird credit card charge from another country, that is fraud detection spawning a totally unusual pattern in milliseconds. It's also heavily used in predictive analytics to forecast business trends and in natural language processing to help machines actually understand the messy, complicated words we humans speak and type.
Now, it's time to open up the final innermost layer of our Russian doll for Section 3, diving into deep learning.
So if ML is a subset of AI, deep learning is a highly specialized subset of machine learning. It takes things a massive step further by actually mimicking the physical structure of the human brain. It uses these things called multi-layered artificial neural networks. These incredibly dense, interconnected layers allow the system to process really complex, messy, unstructured data. We're talking high-resolution images, raw audio, massive libraries of text. It just automatically learns the nuances from the data without a human ever having to hold its hand and point out what to look for. When you open up this deep learning toolkit, the sheer variety is just wild. We have convolutional neural networks, or CNNs, which are the absolute rock stars of image and visual data processing. This is exactly what lets a self-driving car see the road and dodge pedestrians. Recurrent neural networks, or RNNs, handle sequential data, which is perfect for stuff like live speech recognition. Transformers handle long-range dependencies, powering modern instant translation. And of course, generative AI, which builds on these deep models to actually create entirely new, totally original human-like text, images, and video, just like we see with incredible tools like ChatGPT or DALL-E.
With our Russian doll fully unpacked, let's head right into Section 4 and see how these two data-driven approaches stack up head-to-head.
So, the big question: when do you use which tool? It all boils down to a few key trade-offs. Machine learning is absolutely fantastic when you have small to medium data sets. It relies on manual feature engineering, which basically means a human actively helps to find what the algorithm should be looking for. The models are simpler, they train a lot faster, they can usually just run on a standard CPU, and this is huge, they have high interpretability. You can easily explain exactly why an ML model made a specific decision. Deep learning, though, totally different beast. It requires massive, large-scale data sets. It automatically learns its own features, sure, but the models are incredibly complex. They take way longer to train, demand highly specialized hardware, and have very low interpretability. In fact, they're often considered a black box where even the brilliant engineers who built them aren't exactly sure how the network arrived at a specific conclusion.
Because deep learning demands so much information to function properly, we really need to look at Section 5, the big data engine.
Here's the truth. Deep learning simply does not work without big data. Because these deep networks contain millions, sometimes billions of parameters. Feeding them a small amount of data leads to a nasty problem called overfitting. It's exactly like a student memorizing the specific answers to a practice test, but then completely failing the real exam because they never actually bothered to learn the underlying math. Having massive, incredibly diverse datasets is completely non-negotiable. It prevents that memorization and improves generalization, ensuring the model actually performs reliably out in the messy real world when it encounters inputs it has literally never seen before.
And processing all that big data? Yeah, that requires serious horsepower. While traditional ML can chug along just fine on the standard CPU inside your typical everyday laptop, deep learning relies heavily on GPUs, graphics processing units. Gamers have known about this processing power for years, right? But GPUs are incredible for AI because they can process thousands of mathematical operations in parallel at the exact same time. This vastly accelerates the time it takes to train these massive models. It's the whole reason cloud AI platforms are so essential today. They provide on-demand access to this highly scalable, super specialized computing power.
Let's bring all of this highly technical information down to earth. Let's look at Section 6, your AI learning path.
The AI revolution isn't just locked away in academic research labs for scientists in white coats. There is immense value here across almost every role in 2026. Students can start building future-ready skills for high-demand, high-paying careers right now. Data analysts can totally level up their insights by building their own predictive models. Software engineers can integrate powerful intelligence directly into the everyday apps they're already building. And business professionals can leverage these core concepts to optimize operations and make truly data-driven strategic decisions. Grasping these tools gives you an incredible edge no matter what industry you're in.
So how do you actually get started? The roadmap is incredibly practical and totally manageable. Step 1, start with no-code or low-code platforms. You can use visual, drag-and-drop tools to understand the core concepts of data pipelines and models without having to write a single line of code. It's really all about building your intuition first. Once you have those concepts down, move to Step 2, traditional machine learning. This is where you learn basic Python and use popular, super accessible libraries like scikit-learn to start building your own models. Finally, once you have that solid coding foundation, advance to Step 3, deep learning. Here you'll tackle the complex stuff, neural networks, CNNs, and transformers using heavyweight frameworks like TensorFlow or PyTorch. So we did it. We unpacked the whole Russian doll. You now know the difference between the broad umbrella of AI, the data-driven engine of machine learning, and the complex neural networks of deep learning. The landscape is evolving faster than ever before, but the roadmap to get involved is surprisingly clear. The tools are way more accessible than they've ever been, and the foundational knowledge you've gained today is the absolute perfect springboard for your own journey. The only question left is, which path are you going to choose in 2026?